And hello and welcome back. Today I will continue in the series of mathematicians with whom our students come into contact. And as usual, the students we meet are gems in the raw as they wait to be polished by us. The timid or the bold, the coarse in the mold, shine as a teacher's love unfolds. Let me share my story. And here we go. Today's story is the third in the series, and it is about Pythagoras. Every student who attends middle school encounters right triangles. Many learn how to recognize the right triangles by the little box placed in the square corner. Sometimes the name Pythagoras comes up, sometimes not. What is Pythagoras' relationship to the right triangle, and who was he? The answer to both questions are part of the story. This is a picture of Pythagoras, who was born in 570 BC and died in 495 BC. He lived the ripe old age of 75 years. Observe that the years went backward during the before Christ period until the AD, Anno Domini, in the year of Christ. So they went backward. The year of Christ was 0, and then we started with 1, 2, 3, 4, and we come to 2023. We are 2023 AD, the number of years since Christ was born. Continuing. Pythagoras had no last name. He was simply Pythagoras of Samos. He lived on Samos, a Greek island. He was a philosopher and mathematician. How did it come about that he gave his name to the Pythagorean theory and becoming eponymous? To become eponymous is to give one's name to one's work. So not only was Pythagoras eponymous, so were Fibonacci and Pascal. We'll hear about Pascal later. Students first explore lessons with the right triangle in 7th grade, and later the whole world of Pythagoreanism explodes into trigonometry and related functions. Big stuff. The Tunnel of Samos. Back in the 6th century, during the time when Pythagoras was alive, people who lived on the island of Samos almost ran out of drinking water. The people lived on one side of the island, the water was on the other. They could not access that water. Brilliant engineers constructed a tunnel 1,036 meters long. That's about 3,399 feet. They constructed that tunnel completely through the island at Mount Castro in Samos to serve as an aqueduct. The aqueduct would provide water to the people. They constructed the tunnel from both ends at the same time. It was a bit of genius that they were able to connect in the middle. The California Institute of Technology archives much of the engineering expertise of the tunnel. There is actually no writing associated with Pythagoras. The tunnel was built by the engineer Eupalinus and his counterparts in the ancient archaeological site of Pythagoreon. Much of the engineering work related to the building of the tunnel was not Pythagoras' work. Everything just happened to have his name because he was born in that time, and he was this famous mathematician. Interesting. Pythagoras, however, is known for his right angle theory. The right triangle was always one side, has always one side longer than the other two sides. The longest side, called the hypotenuse, is equal to the sum of the squares of the other two sides. This theory can be confusing to young learners. We use graph paper, Descartes' discovery, to demonstrate how it works. Now, Descartes was after Pythagoras' time. And so here is a little bit about the graph paper, Descartes' discovery, that we use in our classes. The red side is actually the height, and in this triangle, it is the shortest side. The 4 units, that represents the base. 5 units in blue represents the hypotenuse. The hypotenuse is always directly across from the right angle. And that's what I explained in the little box on the side. The math of it is written as well. The 3 squared, 3 units by itself, 3 squared, 9, plus the 4 units squared, 16, equals 25, the same as 5 units squared. And that is it in its simplest form. This is a right scalene triangle with angles of 90, 60, and 30. 90, 60, and 30. I hope teachers can spend more time sharing some of the stories of the people associated with the math in our textbooks. Thank you. See you soon.